Okay, so today we will be trying to understand threads, what they are, what their purpose is, and how do we implement them through C. You basically the basic of everything. We won't go deep into anything. So this is to give you kind of a crash course in idea about what threads are, why they are there, and how do we achieve that purpose that we are going to state as to why they are there. As I usually say, as I always say, how should we start whenever we are trying to do something? How should we start? We should start with the objective. Okay? So objective is paramount. If you don't understand the objective, you don't understand anything. So what according to us is the objective of having threads? Okay, so first thing is we want tasks. Some tasks, we are into programming, we are building a solution. We want some tasks to run parallelly. They are independent tasks. They may be independent, they may be semi-dependent or anything, but largely we want to run them independently in parallel. Okay, so we should be having them in parallel. Okay, now the question is, if we want these tasks to run in parallel, why don't we have different processes for that? Okay, why are we bringing in some new concept called threads? Okay, so that's where the objective comes in. Threads make it much easier to share data between them, and it reduces the switching of the context. Basically, it's faster to switch between threads than switching between process, because we may be having single CPU, okay, and the CPU must be switching between threads. It may be scheduling this thread first and then moving to this thread, so there is a context switch between them. If there are processes, then the context switching is more expensive. It takes more time, it takes more CPU cycles, and that is why we use threads rather than processes. So that is the objective. First objective, to make tasks run in parallel. Second, being more inexpensive when we are doing that. Okay, that is understood. So for understanding threads, we first need to understand how a process looks into the memory. So this is how a memory looks into the code. It has a low virtual address, it has a high virtual address in virtual address space. It keeps the code somewhere in that, okay, and it keeps what else? It keeps data someplace, okay. What else? Okay, and command line arguments. And there is a heap, and there is a stack. These are the major ones. Some people can say that data is also two parts basically. One is uninitialized data, and also known as BSS, block started by symbol, and other is initialized data. Okay, and then there is stack, and then there is heap, and each function brings its own stack. So whenever we call a new function, it gets allocated a frame on the stack, and heap is used for dynamic memory allocations, etc. Right? So what happens is that they grow in opposite directions. Okay, and in case of some kind of memory leaks and all, these boundaries may overlap, causing a stack overflow. Okay, you understand? So this is a process, how the thread differs. We will see now. So in another way, we can say that a process looks like this. If this is the process, then it has code, right? What else? It has its own data, it has its own files, it has its own registers, and it has its own stack. Okay, let's say this is what a process looks like. On the other hand, when this is divided into threads, let's say one process defines a solution, and then that solution requires multiple tasks to be running parallelly. Okay, then this process can spawn multiple threads. Okay, it can itself divide into three lightweight processes. Threads are also called lightweight processes because of the same reasons. Switching is easier and data has to be managed only at one place, you'll see. So if this process were to work as three threads, in that case they will share code, data and files, but each of the thread will have, this is thread 1, this is thread 2, this is thread 3, each of them will have their own stack and registers and stack, they will bring in their own. You understand? So why do we call thread a lightweight process? Because a lot of context is not to be switched when the context switching is happening. Okay, so it makes switching faster and it can easily share data because data section is the same. Understand? Now we move on to how do we have fun with threads in C. Okay, so in C, I'll be talking about only POSIX library. Okay, Unix based POSIX library. So in C in POSIX we use libpthread. Okay, so it's a pthread library that we use, and what do we use it for? Okay, there are multiple tasks, some basic, some a little advanced. One is creating thread, and where there is creation, there is
destruction.
Exactly, or destroying the threads. Okay, then we use them to pass message or data between threads. Okay, message or data passing. Okay, then scheduling, we can provide some parameters while creating thread that can define what's the priority of what the scheduling priority of this particular thread is going to be, etc, etc. And saving and restoring thread contexts, we can do that also. So basically libpthread library in itself provides a lot of flexibility for us to make our job easier when we decide to have parallel executions of tasks in our solution. Clear? Okay, questions. What makes threads lightweight?
The sharing of data.
Yeah, and what does that does? The sharing of
the context switching is easier.
Context switching is faster. So it's a lightweight process. It's a process in itself, but it's lightweight because switching would be faster. Okay, fine.
It's inexpensive, obviously.
Inexpensive because of that only, because context switching is faster. So if somebody asks you to define a thread, you can simply say thread is a lightweight process, and then they will ask you what do you mean by lightweight process, then you can say this is what makes it lightweight process. Okay, so objectives are clear, and how do we achieve that objective? Through libpthread library in case of POSIX, and these are the basic functionalities that it. So first up is a function called pthread create. Okay, I am going to write its prototype first. It's int pthread create. Okay, easy. Pthread library creating a thread. The first parameter is pthread underscore t PID. Second parameter is pthread attribute. It's a const. We won't be able to change it once this function call is made. Pthread attr underscore t and asterisk attr, let's say. Okay, the third argument is start routine. Void asterisk, it returns a pointer, your start routine pointer, and it takes the argument also as void asterisk. Okay, and an argument. You understand this function call, you understand a lot about the usage. Okay, so pthread library takes 4 different inputs. Now, do you know what pthread t is or pthread attribute t is, etc., etc.? At this point you don't, right? So these are provided by pthread library. So what will you do first? You will include that library whenever we are going to be using these calls. We will be including pthread.h. Okay. Okay. Now this can be null. You can pass this as null. Okay. So what does this does? What does this parameter does? It provides attributes to the thread. A thread can have attributes. A thread can have properties. Okay. What kind of attributes? Whether it's detached or not from this particular process, we can do that. We can make a thread detached from that process and claim its storage, whatever storage it is taking. We can do that. It's kind of an advanced thing, not the starter pack, but we can do that. So that's one thing. It can be detached or it can be non-detached. We can define whether or not it's unbounded. Okay. We can define what stack size it can have. We can manipulate the stack size, and we can define what this thread's priority going to be for scheduling, etc., etc. These types of attributes we can define. What if we send null? What happens then? Any guesses? If we send null, then there is a list of default parameters of all that. Whatever system sees fit, it can allocate that stack size and so on. Okay? Go home and study what the parameters do and what the default parameters are. That will be very helpful. Okay? Okay. So this is attributes. Fine. Another thing is start routine. This is okay. And in case of null, what happened here? Default attributes. Okay. There is another call, pthread attr init. You can do like, you can create a pthread attrt object outside and then init it and then pass it here also instead of null, but they do the same thing. So I don't know why it is there. So that also initializes the attribute object for default attributes. It's the same thing as passing null.
So it's a different function.
Yes, pthread attr init. Just okay. Takes this attr object and fills it with default attributes. Okay. Then we have a start routine. Okay, so you had, let's say, a code. Must have started somewhere at main. You reach some point and you start trying to make you decided here that at this point in execution, a new thread should be spawned and take up some particular task that it should perform. Okay, how you can create the thread here by using pthread create, but how would you specify to this thread where should it start executing? Okay, it should also start executing like the main thread, the process when you initiate, it has to start from main. So this thread also has to start from some place, and start routine is that place. So here you give that particular function where it has to start execution. Okay, start executing at this routine or function. Fine. Okay, that's another thing. One more thing is, it seems to take a void argument. Okay, but here we are only passing the function name, only passing the, as you can see, the pointer to the function. Okay, we are only referring that this is the function used, but it does take a void argument, but we cannot pass it here. So what could be the point of this? It's very simple. If you think, we are starting a new thread whenever we are starting, just like a main function, main process may sometimes need a set of variables, set of data that we can do using command line variables, right? Args or something, argc, argv. This thread may also need some data to start, right, at the start, so that we can pass here data to be supplied at start of a thread execution. ठीक है जी? You understand? This is fine. And how would you do that? If it's always void asterisk, it's simple. You will create a structure whichever you want to supply. Let's say supply structure. Okay. Type def struct supply here. Okay, you create its object. Okay, object created. Then you will fill it, and then you will typecast it into void asterisk the address of this object. Okay, and sorry, it has to be a pointer. Okay, dynamically allocate pointer. That's the only way it will go into data part, and you can supply it here. After typecasting into void, you will supply it. The start routine then will again typecast it into that structure and use the data. Okay, and the first one we came into it, the last PID, pthread t. So this simple variable, what it does is, if a thread is created, then its thread process ID is copied into this particular variable PID. So there are a lot of things that would need PID as an input for, if you want to do something between the threads. Okay, like if one thread wants to destroy the other thread, for example, how would it do that? It would need something to point to that thread, and that is threads PID. So this we set. When we are sending, when we're creating the thread, this is set if the call is successful. Okay, and how do we know the call is successful? Return value will be 0. Return value will be 0 in case it's a successful call, and non-zero if unsuccessful. Fine. You understand pthread create?
Yes.
First one is always, we have to go very thoroughly. This picture is clear, I'm hoping. Okay. Next in line is, we will try and understand thread termination wait. And okay, so if a thread, let's say it's thread 1, is in execution someplace in the code, and thread 2 is in execution in some places at code, and thread 1 decides that it will not conclude its own execution. It doesn't want to terminate before thread 2 does. It wants thread 2 to terminate first. Okay. In that particular case, it can make a call called pthread join here. And as I said, PID or TID is going to be very important. So that's why it requires TID here. Okay. For this thread, TID of thread 2 has to go here, and another thing called status. Okay, so status we can pass null. In that case, we don't require that information. Other than that, when we make a call to TID, if we pass null, then simply whenever the thread 2 is terminating, this thread 1 will now unblock. Otherwise, this calling thread blocks here, waiting for thread 2 to terminate. Okay. If we pass null, good and dandy. Thread 2 has once thread 2 has terminated, thread 1 can move on. If we have specified a variable here, that means the exit status of thread 2 will reflect here, whether it exited correctly or not. Like, you know, what was the status of thread 2 when it terminated. It may not have terminated successfully, right? So that, and next is another one is detaching a thread. Okay, what is detaching a thread? It's like we don't need that thread anymore. Okay, so but we need its storage. We want its storage. We don't want the thread. So basically, it's a process space. 3 threads were running, and process suddenly decided that this thread we don't want, but we want to claim its space. So it's like, it's an alternative to pthread join. Simply we call this function called pthread underscore detach, and we again provide the TID. Understood? We again provide the TID. So what it does, whenever the other thread is terminating, the calling thread will block here, and whenever the other thread terminates, then the thread is detached. So the thread will go through its own execution pattern, whatever is defined by the code, and then it will just simply go out of the execution. But whatever storage it has been taking up, that will be claimed by the process. Okay, understood? So that is pthread create. Okay, then we have a pthread self. A function may need its own PID sometimes. Okay, maybe it wants to change its own thread attributes. Okay, so for that we have a call known as pthread self. Then pthread t. Okay, the return value will be thread ID this time, and a call to pthread self. So whichever process is calling that process's thread ID will be returned. Okay, that is clear. Okay, there is comparison also. If we have somehow happen to have 2 pthread IDs, then we can call this particular function. The prototype is this: pthread equal and again TID1 and simply TID2. Same type. If they are equal, then it will be some non-zero value. In case of equal, if they are not equal, it will be 0. These things we can. Now sending a signal to a thread. Okay, so this is important. This is actually quite interesting also. So there is a few signals that are defined in signal.h. You may have heard of sigint or sigkill. Sigkill is like a hard kill, etc. that we use. We can send those signals from one thread to another, and we can actually implement, if we cache those signals, we can implement some functionality over there. Okay, so if we have taken included signal.h, then we can make a call to pthread kill. Pthread kill with the parameters, of course, thread ID and the other parameter is going to be signal, and this signal has to be one of the signals that is defined in signal.h. Okay, understood? The name suggests kill, but it can send other signals too. Okay, and then terminating a thread, and this is going to be last for today. Sometime when we meet next, we will be talking about thread synchronization, where we will see how the threads synchronize the data exchange between them, because they will be doing stuff, they will be doing things on same data. So it's so the data becomes what?
Coherent.
Data becomes a critical section. Okay, you know about critical sections? Critical sections are, it could be data, it could be files, it could be other resources. Something becomes a critical section when multiple processes are trying to access that or execute in that region at the same time, and that can lead to race condition. For example, both the processes are trying to work on some variable. One is adding it, one is doing something else, subtracting it or what. So it has to happen in a manner that is, it has to happen in a manner that not both are simultaneously doing. There has to be a, an order between them, an organization between them, a kind of protocol of doing that. So for that, if threads, as I said, are anyways, it's for the next lecture. So terminating a thread. Okay.
Yes.
Terminating a thread, that is important actually. So a thread can terminate in 3 ways. Okay. Can terminate in 3 ways. One is by following its destiny. It serves its purpose. Whatever execution path was defined for it, okay, it must have started from, let's say, function 1. It must have started here. It may have called another function, function 2. Okay. Then it may have reached function 2. Then it may have called other function, and so on and so on. But after the call, it will return to here and then return to here and return this part. Once it's outside of that, it's done. Its purpose is done. Just like main function. If it's outside main function, the main thread, the main process is done. So this can happen returning from its first outermost procedure will terminate it. Another is by calling pthread exit. Okay. One thread can call pthread exit on, no sorry, I'm wrong here. pthread exit is this particular thread itself calls pthread exit on itself. Okay, there's a thread, it's running, it's executing, it reaches some condition where it thinks that okay, I have to exit now, I don't have anything to do anymore. In that particular case, it can call pthread exit. So return type is void, simply.
It's just like a return statement.
It's just like an exit statement, not a return statement.
For thread.
Return statement returns something to calling function. Okay, pthread exit is not returning anything.
Yeah, because it's a void pointer.
It's like exit function. We have exit in C, right? Like exit, and we pass exit success or exit failure there. It's more analogous to that than return. So it's like a pthread exit, and it can return a thread. It can return a status. Now this completes the cycle. This completes the cycle. Remember, if some thread was joining, it could join with the status. Okay, thread ID and status, and it can catch the status. What was the status of termination of the other thread?
Yes.
It was the calling thread was waiting on p join for the other thread to terminate. So if we pass null, it won't care how the other thread terminated. But if we set up a status variable there, that status variable can catch this part, this thing. If the called thread, which is now terminating, is terminating by pthread exit. Okay, getting it? And then there is pthread cancel. So one was fulfilling the destiny, going through the whole lifetime that was intended. Other was calling pthread exit forcefully, thread calling it by itself to terminate itself. And then there is int pthread cancel. What it does is, it takes a thread ID, and it terminates the other thread right in the middle of it. It's like control C on the terminal, something like that. Not exactly control C, because if we wanted to control C, we would be doing pthread kill with a sig kill. Okay, TID and sig kill. So kind of similar. It's cancelling this particular thread. Okay, so these are the basic procedures that we use from pthread library. I think what we did today was we try to understand what is the objective of creating thread, what purpose do they serve, okay, and how they make our system better, solution better. And then we looked into POSIX calls, some of the POSIX calls through pthread.h library, and we went through creation of thread and waiting for some thread to terminate, and we studied about termination of a thread either by itself or by some other thread, and comparisons of thread IDs, getting a thread ID, how we can explicitly get a thread ID for itself, detaching a particular thread from the process and claiming its storage. So yeah, I believe this is the basic. You can go deep and you can study more. Next time we meet, we will be studying how do we synchronize the data between the two threads. Two very important and very interesting topics are going to be in there. One would be mutex, one would be semaphore. Very interesting topics, very important topics, some of the favorite topics of interviewers. So next time.